So today we are going to build a telescope with my 63 mm diameter objective lens with focal length of 700 mm. So today we are going to build a telescope with full accuracy, and we are also going to see some basics of telescope. You can see that how our lens is going to bend the light beams, and the light beam will meet at this point, and we call it focal point, and the distance between focal point and lens called the focal length. This focal point can move toward our objective lens, or it can go away from the objective lens. It depends on the distance between objective lens and object. If object is too far from our objective lens, then this focal point will go toward lens. If object is near the lens, in this condition this focal point will go away from the lens. So we need to move our eyepiece to get focus. The focal length of this eyepiece is 20 mm. If I put this eyepiece in distance of 20 mm from focal point, then the lens of this eyepiece is going to make all the unparallel light beam parallel, and this parallel light beam going through our converging lens inside our eyes, and our lens is going to make a focal point. Then the light is going to fall on our retina, and this is how our eye can make an image on retina, and this is how we can see through a telescope with help of an eyepiece and objective lens. If I use big lens instead of this 63 mm lens, for example, if I use 90 mm lens with same focal length, then I can get more light, and this angle will be greater, so I can use a little bit bigger eyepiece to get more clear image and the greater quality. So this is rack and pinion mechanism to move our eyepiece forward and backward to get focus, and this is 63 mm PVC pipe, and it coated with black paint. You don't need to make it black from outside, but it should be nice matte black from inside, and the paint layer should not reflective, otherwise unwanted light beam is going to jump on your eyepiece and it is going to make your image very haze. So to get rid of it, you need to paint your inside with non-reflective black color, or you can use a chart paper, a black chart paper. It will work very nicely. And the length of this PVC pipe is 68 mm, and some length is covered by this mechanism. So there is tons of mathematical formula to calculate everything about lens, but we don't need to jump on it just because we are going to make a very simple telescope. So now we are going to fix this lens on the PVC pipe. I'm going to use this reducer. You can buy it from any hardware shop. So this is reducer. You have to put our lens inside 63 mm side, and this 75 mm side will prevent unwanted light to reach our lens, so it is also going to be very useful. This lens should nicely sit inside this plastic body. It should not tilted in any direction, otherwise we are going to receive a focal point toward the boundaries of PVC pipe. It should be nicely sit inside this to get focal point in very center of PVC pipe. So still I have to receive some important parts like 90-degree mirror. This telescope makes inverted image. You need a 90-degree mirror to fix it. And I also waiting for mobile stand for this telescope, which is very important to see through this telescope using mobile. And I have to receive some eyepiece. So I'm going to receive these items within 3 to 4 days. Then I'm gonna show you how this telescope work and the magnification of telescope. We are going to see through our telescope using mobile phone. So thanks for watching my video. We are going to meet again on my next video, which will be all about seeing through my telescope using mobile phone.